Okay, this is example 2 from 8.2 in Math 20-1, and it's got everybody's favorite thing in a math problem, which is words. Right? It's got this crazy, I mean, not crazy, crazy is the wrong word. It's got a big paragraph descriptor of what's actually happening in this question. And the best thing you can do is try to break it down into smaller parts. So it says determine two integers, and then it talks about smaller number and larger number. So I'm going to say that x is the smaller integer. I'll just put int for integer, and I'm going to say that y is the larger integer. And I know that this feels ridiculous and pedantic, and why do I need to do that? Identifying what your variables are makes it a lot simpler to write out what they're telling us, because it says that the sum of the smaller number and twice the larger number is 46. And then we have one equation. Now, the second sentence is tougher. It says when the square of the smaller number, so that's x squared, is decreased, so subtracted by 3 times the larger number, the result is 93. Now, that hopefully does look pretty familiar because this is, oops, sorry about that, a systems of equations. And it is still a quadratic linear because x plus 2y equals 46 is linear, x squared minus 3y is equal to 93 is quadratic. Now, it is totally up to you if you want to use elimination or substitution, but I'm a big fan of showing you both. So I'm going to do this via elimination, which means I need to set this up so the coefficients are exactly the same or additive inverses of each other. So -3 and +3 are additive inverses of each other. Now, the way that I'm going to do this is if I look at 2y and -3y, what I could do is I could write the multiples out. Now, I don't want to change the variable, but if I took 2y and multiplied it by 2, I'd have 4y. If I have 2y multiply it by 3, I'd have 6y, and I could keep going until I'm sick of doing this, which I already am. But what we're looking for is a number on both lists, usually the smallest number on both lists, and then we can manipulate both to have that coefficient. Now, you have done this before. This is called the least common multiple, and I think it's massively crucial to understand that all the math you've done up to grade 11 isn't useless. It was building, and I don't want to say basic, but building those foundational skills that we end up using in, Math 20-1 and calculus and basically all math after junior high or in junior high as well. So what I'm going to do is do the same thing for -3y. So if I multiplied by 2, I'd have -6y, or by 3, -9y, or -12y, and so on. What I'm not going to do is check like 3y times 1.7. I don't want to make this uglier than it could be, or is, I suppose. And so I hope we notice that +6y and -6y are in both lists. Now, why that's such a big advantage is if I took the top equation and multiplied it by 3, what I would have is 3x plus 6y is equal to 138. If I took the bottom equation and multiplied it by 2, I'd have 2x squared minus 6y is equal to 186. And why this is so important is now we have this right here. +6y and -6y. This is now perfectly set up for elimination. Now, I don't want to subtract the equation because 6y minus -6y is 12y. That's no good. But 6y plus -6y is 0y. And now that variable has been eliminated. So what I'm going to do is I'm going to add those two equations together. So 3x plus 2x squared is simply that. 3x plus 2x squared. Those aren't like terms. We can't do anything with it. But 6y plus -6y is 0y. We don't need to write that, but I am going to, at least for this question. And then I would have to do 138 plus 186, and that's 224. I'm actually just going to double check that on the calculator because if I make a mistake there, the rest of this question is kind of impossible to do. So pretty important we get that right. I did get it wrong. Look at that. Glad I checked. That should actually be 324. Okay, the advantage to this is even though this isn't particularly nice looking, it is now a quadratic equation. I'm going to move that 324 over right now. It's a quadratic equation with only the single variable in it, which means we can solve for this regularly, I suppose. We are going to need it a little bit later. So although we don't particularly need it, I'm going to use the quadratic formula here. So that means that the solution to this is that x is equal to -b, so -3, plus or minus the square root of b squared minus 4 times a times c. Maybe just to make this a little bit clearer, I'm just going to identify up here that a is 2, b is 3, and c is -324. And then I'm using the quadratic formula, which is on your formula sheet. And then that's all divided by 2 times 2. And then all I'm going to do here is I'm going to clean it up as I go. So -3 plus or minus. I'm going to put that radical or the discriminant into my calculator really carefully. So it's 3 squared minus 4 times 2 times 324. I get 2,601. And then it's all divided by 2 times 2, which is 4. Now, conveniently, or not so conveniently, because this question was, I'm sure, designed this way, is 2,601 is a perfect square. So I get -3 plus or minus 51 over 4. So my two solutions are x is equal to -3 plus 51 over 4, which is 48 over 4, which is 12. Or I have x is equal to -3 minus 51 over 4, which is -54 over 4, which is an ugly number. It's 13.5, -13.5. Now, before we go and find, the solution using both those x's, the question said the numbers are integers. Is -13.5 an integer? Well, no, integers don't have decimals. So this cannot be a solution. And that's really handy. That this happens a lot in word problems like this, is they'll put something in the question about how the numbers have to be natural numbers or whole numbers, or in this case, integers, and that really guides us as to what, can or cannot be an answer. Now, we're not done yet because the question wanted two numbers. We only have x. We need some technique for finding y as well, and I am going to use this equation. The reality is that it doesn't matter. But if I can avoid having to square a variable, I am going to do that every single time because it's a little bit easier to solve. So what I'm going to do now is I'm going to take my x is equal to 12, and I'm going to plug it into x plus 2y is equal to 46. So I'll write that here, that we're taking the first equation that was given to us, and I'm going to put that x is equal to 12 in there. So 12 plus 2 times y is 46. I can subtract the 12 from both sides. 2y is equal to 34. When I divide by 2, I get that y is equal to 17. Well, 17 is an integer, and 12 is an integer. Now, the question didn't specifically ask us for it, but I always worry I do these questions wrong because there's a lot happening here. So what I recommend is that students check. And if I've done this correctly, just got to get that number right, I should be able to put my values of x and y into my equation and get 93. So x was 12, so 12 squared minus 3 times 17 should equal 93. 12 squared is 144. 3 times 17 is 51. Guess what 144 minus 51 is? It's 93. And so we know that holds true in that at least second equation. Now, it's worth mentioning that that's not really a full verification. We should check it in both equations, but we didn't have to verify in this problem. I just think it is a good habit to get into. And then B says, solve it algebraically. We did that. What is the code that gives access to the site? It said that it's smaller number first. So the code that would let us into whatever this site is 1217. I write it like this because these types of questions are actually great for numerical response because that's a nice kind of 4-digit answer that we can put on an answer key.